Assalamu alaikum everybody. We'll talk about Hub today. Hub works at a physical layer of the OSI model. We know that there are 7 layers in OSI model. We'll discuss this later on. And the physical layer is the one layer, and it is used to set up LAN hubs. And we know that local area networks means it is restricted to a small geographical area. Maybe office building, a school, can be a local area network, university campus can be a local area network. So we need a central device like hub or a switch. We are focusing on hubs today, and if you want to connect some devices using hub, we need that device with multiple ports. So hub can have multiple ports. Suppose if this is the hub, then this hub has multiple ports. Suppose if I want to connect 10 computers, I can connect 10 computers through this hub, because I have 10 ports in this hub. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I can establish 10 computers as a local area network through this hub. And if I have 20 computers, I'll bring another hub with 20 ports. So we can extend our network accordingly. But hub has some disadvantages also, and we'll discuss about it. So we are going to use a star topology in here. In star topology, you can see hub at the center, and we have devices, the end devices, computers, 5 computers connected, and we'll see what is working principle of hub now. When a packet arrives at one port, it is copied to the other ports so that all segments of the LAN can see all packets. For example, if there are 10 ports in a hub, and if some computer is sending a packet in one port, then the data is copied in all remaining 9 ports. And if there are 10 ports in a hub, if one computer is connected to one of the port is receiving incoming packet, and then the packet is forwarded to the remaining 9 ports of the hub. This is the working principle of a hub. If you do not understand anything out of this, we'll see how it works, so that can be clear. Working of hub, we have a computer, and let's assume that this computer is connected to this port, and this is the cable that is used to connect this computer and a hub. And now we'll recollect what in order to connect a computer and a hub, since computers and hub are different devices, we need to use Ethernet straight through cable. So normally Ethernet straight through cable is used to connect this computer and a hub. Now let's assume this computer is somehow connected with this hub, and now if this computer wants to send some data, this data is actually sent to this port. Now what this hub does, it copies this information to all the remaining 9 ports of the hub. So this is what it is working principle of a hub. We'll revisit it again. Suppose if this computer wants to send some data to some other computer which is connected to some port of this hub, what this computer does is, this computer sends the data to this port. Now this port that receives this packet, this hub copies this data to all the other ports of the hub. So this hub copies all the data to the other ports of the hub, and all the devices that are connected to the hub will receive a copy of it, whether they needed the data or not. In a hub, every data is broadcast to all the nodes in the network. This is what is the drawback of this hub. We'll see the working of hub using Cisco Packet Tracer. CPT means Cisco Packet Tracer. So I'll open Cisco Packet Tracer. This is the ID. On the left side at the bottom, you can see hub there, and this generic hub, I'll place it on the workspace. Let me click on this hub, and you can see that it has 1, 2, 3, 4, 5, 6 ports. I'll put some end devices just drag it to the 6. So I need to connect cable. I'll use the automatic selection cable. Or the straight through cable. Fast Ethernet, which is the port available at the end device, and the port 0 is connected to computer 1. Fast Ethernet to port 1. Fast Ethernet port 2. Fast Ethernet port 3, port 4 and port 5 to the last computer. So a local area network established, and you can see the green dots on both ends of this connection. Six PCs here and a hub connected to 6 ports. These are the ports. Now let's see. Green color means is ready for the data communication. You could also observe that if I switch off the connection here, it will turn red. See? Turn it on again by clicking it and it turns on, and the green light shows that it's ready for communication. In order to establish communication, we require to put in IP addresses to all the computer. So I click on the first computer. Here, select desktop and the first IP address and put in here 10.10.10.1. This is subnet mask. We'll do the same for the next computer. Desktop tab 10.10.10.2. Ten dot 10.10.10.3. 10.10.10.4. Desktop IP configuration 10.10.10.5. Subnet mask appears automatically. 10.10.10.6 for the last PC. Now let's check whether I'm able to communicate with each other. So let me go on to the third computer, check what its IP address is, and its IP config, and it will give you the IP address that is here 10.10.10.3. So I want to send it to 6. Command prompt ping 10.10.10.6, and it will give you replies. You can see there, and all the sent packets are received at 6. So far we have established a local area network. To understand working principle of a hub, instead of using the real-time mode, on the right bottom we can see a simulation mode. Here it is. Let me close it. This is the simulation mode. We are now in the simulation mode. Let me send a packet from PC to the other PC. That is, this one is the packet PDU. I'll select it, take it to the first PC, and then click on it and the last PC where I want to send it. This is status shown in progress in the simulation mode. So let's capture forward. Goes to the hub, and it's copied 5 ports connected, so it will have 5 computers. What it does is, after receiving the packet, it forwards all the data to all the ports, the data it received from the first computer. This is the basic principle it broadcasts. The 6th computer was supposed to be the actual destination, and it should accept, and all the remaining will reject. You can see the cross and the tick mark. Next step, the 6th PC will send the acknowledgement, which will again broadcast to all the remaining 5 PCs. The middle 4 will reject it, but the first one, which has sent the first packet, will acknowledge it. So this is what the hub works like. Let me do it again. first PC and the sixth PC. It can be done with any PC. Let's send the packet. See, it's broadcasted. Here you can see, if you go to the OSI model, it is at the layer 1, port 0, OSI model. It is the device that is working in layer 1. Capture, broadcast it to all the remaining ports, except the one which has sent, and the others are denying except the one which it is intended for. And it accepts the packet, sends the acknowledgement. Click again, you can see the sending acknowledgement, and it was again broadcasted. It will forward the data to all the ports. The one which was the actual sender will accept it, and the remaining will discard it. So that is what the working principle of a hub is. There is always a serious problem with broadcasting. So if there are 100 computers, 500 computers, or maybe 1000 computers, this broadcast floods the entire network, and that is the problem with the hubs. We know that communication is successful, and we have established a local area network using a hub. A local area network using a hub in Cisco Packet Tracer, as we have seen. Now we'll see pros and cons of the hub. Hubs. The positive about the hubs are cheaper than switches. So in terms of price, hubs are always cheaper than switches, and it works good for smaller networks, definitely. When it comes to the big networks, hubs definitely create problems with broadcasting. The cons, the drawbacks: issues with the broadcast, as I just said, always issues with the, and also it has no memory, so it's not an intelligent device. It forwards it all what it receives at one port and broadcasts it to the remaining ports, and does not store any data information, so we can say it's not an intelligent device. And finally, the hub runs in half duplex mode. It means it can send data as well as it can receive data, but not both at the same time. Because of these drawbacks only, we are moving from hubs to switches.